Thanks for coming. We've got 4 great speakers and a lot of content to cover, so we're going to have some time for questions at the end, but we're just going to jump right in. So first up we have Ben Cochran from Autodesk.
So hello, I'm Ben Cochran from Autodesk, and let's see, let's get to my slide here. So I'm a software architect for Autodesk, and I run a group called Autodesk Labs, which is an advanced technology group, looking at sort of the next wave of disruptive technologies. And here today I want to talk to you a little bit about some of the stuff we've looked at over the past maybe, I don't know, I want to say 2 years with Amazon services and how we apply them to our customers. But first I want to talk about sort of our customers and what our customers' problems are and how we've approached the problem. So essentially, our customers, we have awesome customers. They design the world. This is an example of the Shanghai Tower. This is currently under construction. When this is completed, this will be the 2nd largest building in the world and the largest building in China. This building is built in a monsoon zone, and so a building of this size in a monsoon zone needs a tremendous amount of simulation. You cannot make a mistake. You can't recall this building. And actually, through simulation, they were actually able to reduce the amount of material for this building by a huge amount. It's something, I can't remember the number, but it was amazing. Actually, this structure, when you turn it, actually ends up closing the wind stream as it goes around it. So again, simulation played a key role. This is also another construction project currently going on. These are our customers who are building the new span of the Bay Bridge. This, when it's completed, will be the largest self-anchored suspension bridge in the world. When building a bridge in an earthquake zone like this, again, simulation is critical. This is another example of one of our customers. They built this bike, completely redesigned from the ground up, using recycled aluminum to house the electrical parts. It's actually a motorized bike. Again, trying to understand the loads on these components was critical when you can't use existing components off the shelf. This is an example of a simulation of an engine, an airplane engine, that was turned into be 1/3 the weight of a similar engine with similar horsepower. You can see here, using simulation like this, you're able to easily visualize and understand the impact of the design decisions you make. And of course, I wanted to just throw a nod to our M&E customers who build all the video games and movies that we make in the world, or that they make. But so, our customers, they design amazing things. They do most of their design, actually, the initial phases, in their minds, on napkins, on whiteboards, having conversations. A lot the same way we build software. And they use our tools, really, it's about documentation. They capture their design in the tool, then they use that tool to validate their designs, to make sure it meets requirements, and take that design to something that can be built, like a bridge or a building. But we want to help them early on in the design phase. We want to give them feedback early on so they can make decisions and choices while they're still in that whiteboarding stage. So let's dive into a little bit about how we can do this with Amazon services. This is an example of a simulation. If we ran this simulation on a large instance, we could run it for 6,000 minutes, one computer, $13. That's great. The value that the customer gets is amazing. But at a better part of a week, this can only happen at the end of the design phase. This is validation to make sure that the design meets the minimum requirements. And instead, with Amazon, we can also rent 400 computers for 15 minutes for the same price. This changes what you can do with design. Now, instead of waiting to the end of the design process, I can try many different alternatives. And in a quarter of an hour, I can understand the results of those alternatives right away for the same price. But even better than that, I can try many more design alternatives. Of course, each one of these is going to cost $13, but that value is enormous. Now I can explore many different design alternatives, and the result is I can pick one that doesn't just meet the minimum requirements, but far exceeds them. And this is an enormous improvement to what customers can provide, what our customers can do against their competition. So that's what we want to do. And that's what we are doing that today in a lot of regards. But when we look at this, these are not traditional web services. We're not looking at many, many services that we pack on one box. Sometimes we even have services that run across many boxes. And they require enormous amounts of memory, CPU, and GPU. So when we ran into this problem, we said, well, okay, this isn't traditionally what you would do with a web service. These are traditionally things that these people say cannot be done on a web server. Well, we did do it, and we did it by building our own autoscaler. And I'm going to simplify things a little bit here, just because I have 15 minutes. But these were our requirements. We wanted to balance our job arrival rate with the amount of workers we had in place. We wanted to guarantee interactive response while we minimize costs. Our challenges are we have a stateful workload. Jobs run for oftentimes in excess of 2 hours. When we automatically scale instances up and down, 25 minutes and even 30, 40 minutes sometimes it takes to scale up instances. And then Amazon bills on an hourly cycle, so we wanted to also take advantage of that. So if we look at this model, we simplify it down, really we have two types of resources. We have what we call an MCU, or master control unit. We have one of these in each region. And then we have instances that run in the region that contain workers. And a job can run on one or many workers. It's really just a way of compartmentalizing a server resource. And we have the MCU is always trying to keep the number of number of available workers within a range. It's pretty simple. And it also keeps a cap on the maximum number of instances that are booting. Inside of an instance, we have workers in two states, working and available. Plus we have some workers that we've tagged as available for overload, and I'll show you how we reuse these. The MCU itself is always trying to keep the number of workers in the whole pool in a target range. And I'll show you how it does this by walking through an example. So here we have the available workers over here on the left with this arrow. We have an instance, and work arrives. OK, we assign it to the first available worker. That makes sense. Work arrives again, and now we've actually run into an area where we're below our target range. So we start a new instance. This instance isn't available when you start it. It takes 5, 15, 20 minutes to start. And while that happens, 2 more workers come along. We've exceeded our 0 amount. We've actually gone into overload in this case. Of course, when this happens, we get a notification. We learn that something is not quite right. And maybe we need to tune our ranges a little more. Well, luckily, the instance comes along and provides 3 more workers that are available. We get back into the normal range. And now our workers are assigned to the new instance. Now, when we scale down, it's relatively simple. As workers leave, we become available instances. Workers become available on that instance. And now we're outside of our target range. We have, remember, the one last job is still on the overloaded slot, or using the overloaded worker. And so we're not going to shut that instance down. But when he leaves, now we can. But we still don't shut it down until the instance has been running for an increment of some multiple of an hour. This actually provides a nice dampening on our instances. You can imagine there would be a very chaotic graph of how often we would start and stop instances. And that hourly rate just sort of dampens that out and makes things run a lot smoother. And so obviously, when all the work jobs are done, we can shut down that instance and we get back into our target range. So just to show you here, I took off the numbers on the left just because I don't think I can show them. But this is a row graph from what we had as our cost per job. So in March, we introduced the auto scaling for a set of jobs that we use. And we were actually running 2 systems at once, so we had only a little bit of benefit on our costs. Then in April, we actually saw the real benefit. And when we continued to tune those ranges, we got a couple emails about overloaded instances and so forth. And then eventually, we were able to reduce our cost by about 5x. So that's pretty much what I have to say. And I just wanted to tell you I'm super excited about what our customers can do and what they can build in the future. So thank you.
Great. Thanks a lot, Ben. So next up, we have Brian Besterman from Pronia Medical Systems and David Rockamora from Control Group.
Thank you. Let's get the clicker going here. So today, so I'm David Rockamora, and today we're going to talk a little bit about HIPAA-compliant applications. I'm the VP of DevOps at Control Group, which is a technology and strategy company in New York City. We do a lot of work, with disruptive technology like Amazon Web Services to transform businesses, products, and spaces. And I'm really fortunate to be working with Brian Besterman from Pronia Medical Systems.
All right, thanks, David. Pronia Medical Systems is the maker of GlucoCare, an intensive glycemic control system. I'm Brian Besterman, the co-founder and CIO of Pronia. GlucoCare is an FDA-cleared software-based insulin dosing calculator indicated for the management of blood glucose levels in the hospital setting. It's an FDA Type 2 medical device. It's been in the marketplace for several years now. And hyperglycemia, and I know this isn't a medical audience, but it's pretty easy to understand, essentially high blood sugars. They're present in about 40% of critically ill patients, and high blood sugars are associated with complications, increased hospital stays, and increased costs. So our system, which is essentially built on web technologies, can decrease complications, decrease hospital stays, and decrease costs, and ultimately benefit patients in important ways. Although till now GlucoCare has mainly been deployed within hospital data centers, we've also been running an EC2 for 3 years through the kota, Kentucky Organ Donor Affiliate. And this is sort of an interesting use case that Dave thought I might want to describe. In brain-dead organ donors, actually, managing blood sugars in them is correlated with improved outcomes in the recipients of the organs. And so by helping nurses manage these patients, we're actually, having benefits. And this is something that is used by traveling nurses across over 20 hospitals in the Midwest, and they're using our system on EC2 instances right now. So let me move to the next slide. Why AWS for GlucoCare? So we really see the push into AWS as something that's going to be an important differentiator for us, and there are 3 main reasons why I think AWS is going to be important to our growth. One is cost. Healthcare, as you know, is expected to grow very rapidly in the next 10 years. But hospitals are still on extremely tight budgets. And being able to go into a hospital and say, you need to first install even, modestly $15,000 or $20,000 in hardware, it can be a tough sell in these times. Also, being part of a large capital expense of a hospital often takes a lot of time for the stakeholders to approve your project. So going with AWS, we can actually envision some alternate scenarios, basically going in and saying you can try our system before you buy it on the web. We can have it ramped up for you. Even at the sales call, we can ramp up an instance of our system configured already for the hospital, exactly what they would expect a production system to look like. And then we also have an upgrade path for them so they can continue using our system as a SaaS service over the internet. Or ultimately, we can connect our system through the virtual private cloud to their data center, or ultimately, if they're a larger enterprise hospital and they're not looking to ultimately run it on the cloud, then we can move the system into their hospital. But the cloud gives us these opportunities that we didn't have before. The second reason why AWS will be really important in hospitals is cutting through the IT bureaucracy of a hospital. When we go into hospitals, signing the contract is often just the very first step in a long process. What we often see after that is engaging the IT resources at the hospital, and sometimes we're project 3 or 4 in a line of projects, so we may have to wait 6 or 8 months to actually get deployed into the hospital. So by saying, look, we can have you up and running in a day on the cloud, and you can start using this, is a huge benefit for us. We can slash our deployment times significantly. The third thing is nurse training at the hospitals. Nurses need to be trained at all different times, unexpected times. We often have to provide test servers to the hospitals. Now what we can do is we can allow the nurses to actually, through a dashboard, turn up test instances at any time and then turn them down, minimizing their own costs. With our system, typically, it's good for an individual nurse to have her own instance of our system for training. So this really gives us a lot of flexibility in training the nurses in the hospitals. So that's, why don't I hand it back over to Dave?
Yeah, cool. Thanks, Brian. Yeah, I think it's interesting. I mean, Brian's a doctor, and he's also like a computer and cloud expert, so it's kind of interesting to work with him. And this is the only time that I've ever worked on a system that has organs connected to a cloud computer, so it's pretty fascinating. We wanted to talk a little bit about HIPAA. I mean, HIPAA is a set of healthcare regulations that any application dealing with protected health information needs to comply with. And it talks a lot, I mean, it's a huge set of regulations that we need to deal with when we're working with a healthcare application, no matter where it is. And I think that, we've been working with Brian, you know, and Pronia to make sure that GlucoCare is a HIPAA-compliant application wherever it gets deployed, you know, in physical infrastructure or in the cloud. And it's been a really interesting journey for us over the last couple of years to deal with it. We ran a webinar last summer to talk to some people about what it's like to deploy HIPAA on Amazon Web Services, and we got a tremendous amount of response. And one of the big feedback, you know, from the whole webinar was that, you know, that's great. Tell me about encryption. That was the only thing that people really wanted to talk about. So which we chose to focus our talk today on. But I just want to point out that it is sort of just one little piece of the puzzle that has to be solved for HIPAA. And there's a whole lot more. We only really have 15 minutes, but we can dive right into that. I think one of the things that Control Group found when we were doing our research into HIPAA compliance and dealing with that and understanding how AWS fits for that, came up with some interesting statistics that I think prove that Amazon is actually a really great platform for HIPAA-compliant applications. So whenever there's a breach of personal health information, the organizations have to send that information to the Department of Health and Human Services. So we went through and collected all that data, and we looked at, when we look at the number of breaches, the number of individuals that were affected by different types of breaches, we found that 84% of those breaches were because physical computers, storage, a laptop gets left in a cab, a flash drive gets lost or stolen. That's why the healthcare breaches are happening. It's not because people are hacking into the computers. It's not because of things like that. So, you know, because with Amazon you're dealing with virtualized infrastructure that's running in a very secure data center that meets all these regulations and requirements that I don't know all the acronyms for right now, but you know, they're up there. We can reduce the physical footprint of PHI in your own data centers and in your own systems, which really, you know, has a huge advantage to protecting this kind of the most common, you know, risk. And another thing that we get to do too is through the use of automation, infrastructure as code, we can describe complete environments and prove that they're actually compliant, HIPAA compliant. We can run audits in the future, and that's the kind of stuff that we're doing with GlucoCare. So we wanted to talk really quick about how the encryption component works at this state. This is, you know, a work in progress. I mean, I know that how many Amazon features were released just today while we were hanging out, and we submitted this slide deck like 2 weeks ago. So, no. So we wanted to give you sort of a taste about how we're dealing with this and how we're delivering the keys to the instance. So Pronia uses secret keys to encrypt the data in the database model, right, Brian?
Right. Yeah. Essentially, we're using password-based encryption for our data. We run on a Hibernate object relational layer and use JSIP to manage password-based encryption. It kind of hides all the complexity of the encryption from us. So the key is really getting the password down to the instance. Once the key is there, the you know, the encryption is taken care of after that.
Right. So the keys are stored outside of Amazon in a whole set of, you know, systems with policies and procedures that's kind of outside the scope of this talk. But it's really important to maintain and protect those keys because they allow everybody to encrypt and decrypt the PHI. But when we're in Amazon and we're starting up a new instance of GlucoCare, you know, what happens is we use CloudFormation to deliver keys to the instances when they start up. We're securing the instances with IAM roles that sort of protect the data as it moves through CloudFormation and gets delivered to the instance. Another thing that we do, you know, like I was talking about the auditability, we use CloudFormation to describe the whole infrastructure, including firewall rules, security settings, file system permissions, things like that, to protect the instances from sort of unauthorized access and to make sure that, you know, that key does exist somewhere in the pipeline, and we use all the Amazon features we can to sort of limit access to that. We also can do things with like multi-factor authentication to reduce the number of people that might have access to the keys. So this is a zoomed in version of sort of how this is happening during the startup of the GlucoCare application. So the instances come up and they have really nothing on them, no software, you know, really just maybe pretty much a base system. But when they boot up, they get an IAM role assigned to them through their CloudFormation description. And then they reach out to the CloudFormation API to get that key and store it in a file. And we store the file in a secure place in the file system with Unix permissions to protect it. So once that's there on the instance, the GlucoCare application actually gets installed from scratch and then configured, and then it begins to start up. And when it starts up, it's going to reach out and pull that key into the memory.
Right. It pulls the key in and it deletes the file at that point. So we don't leave the key anywhere on the instance.
Yep.
And we also actually lock the firewall down at that point as well too. So there's no ability to make metadata calls outside of the instance.
Right. Yeah. There's a number of things that are going on, and we've done. You know, what's interesting about doing the encryption piece. I mean, the encryption is an addressable concern in HIPAA compliance. It's something that most of the hospital customers are very interested in.
Right. It's not an absolute requirement, but when we go to hospitals, they want to know that we're doing it. And we think that it's going to become easier and easier over time for hospitals to have their data stored outside of their own data centers. But that's always the first question that comes up.
Yeah. So, we only had 15 minutes to go through this incredible system, and there's a whole lot more to it that we'd love to talk about. Control Group does a lot of work in HIPAA compliance, cloud consulting, and other kinds of things. And I know that Brian loves to talk about this great product. We're really looking forward to a number of Amazon features that we sort of suspect are on the horizon, such as the ability to revoke an IAM role or to be able to do some more fancy things with the key delivery service from Amazon that we've been talking about. But what's kind of great is that these building blocks are showing up, and we have the ability to sort of modify and update the application to take advantage of new features as they come out. So if anyone has any questions and wants to talk to me, please grab me after the talk or send me an email. We'd love to talk.
All right, thank you.
Thank you.
Thanks, David.
Thanks, Brian and David. Last up, we have Jeremy Shigoda from Stratalux.
All right. Good afternoon, everybody. Thanks for coming. My name is Jeremy Shigoda, and I'm the CEO of Stratalux, and we're based in Los Angeles. What is Stratalux? We're a professional and managed services company that is entirely focused on the public cloud, which builds tailored PaaS solutions for its customers. What does that mean? It means we build and architect solutions on top of Amazon and then manage those infrastructures for our customers if they so desire. We're an Amazon partner, technology partner, and an ops code partner. So in the course of being in business for a couple of years and focusing solely on public cloud resources, we've kind of realized that there are some challenges with cloud-based managed services. And those challenges are, one is the customer architecture. So we get customers that come to us and say, hey, I've got 10 servers and 10 physical machines in this data center here. I need 10 instances onto Amazon, and everything is done and good, and we're happy to go. Unfortunately, that isn't always the case. So you need to remember that when migrating to Amazon, you need to think about the service that you're running, not necessarily the servers. And so because of that, don't think about the number of servers or the types, but think about making sure that your service is available and appropriately architected for Amazon, because it's a completely different ecosystem. And moving into that direction, you need to really think about how to make something available and reliable. Additionally, we work with customers' desire for agility, and I don't mean just simply businesses wanting to get products out the door quickly in an agile fashion, but because we're in the cloud, there's a lot of dynamic stuff going on. Systems are coming on, systems are getting shut down. We want to scale things up and down. There's the whole issue of workload. So as we're migrating customers over to it, we may think that the workload needs this type of infrastructure, but in reality, in order to make the costing better, we might want to scale those down or up as appropriate. So how do we manage this dynamic world of cloud computing? Well, the basic need is consistency from our point of view. So consistency really is how do we create a level playing field that we can then manage our infrastructure. We do that through code. So we use ops code chef to to configure all of our systems, and then we use CloudFormation to orchestrate the system, the servers and whatnot in that area. And I'll get into that in a second. And then lastly, it's efficiency in building and managing our solutions. So we do this for a living all the time for all of our customers, and so we want to do this as efficiently and quickly as possible, and doing this with code definitely helps in that area, as well as managing those solutions ongoing. So the only thing that I've learned is something that has been around for eons, is the only thing that is constant is change. So what is the solutions that we've come up with? The first is leverage cloud-oriented tools, right? What got you into the traditional data center tools aren't necessarily going to work in the cloud environment, and I'll go through a list of those. But there's a lot of great things out there that help us manage our infrastructures. Next is automate everything. We feel that instead of going onto systems and fixing things and setting them up once for our customers, instead we want to fix all of our problems through code. And we use, as I mentioned, Chef and CloudFormation for that. But at the end of the day, I call it disposable computing. So if something is broken, instead of fixing it, what we just do is throw it away and build a new one. Obviously, because we have multiple customers And those customers are running in a standardized environment that we need to support, but also have their own specific needs. We want to standardize as much as possible. So we go through the process of creating cookbooks and recipes for our purposes to allow us to manage our customers in the best possible way. And then lastly, we've embraced DevOps to ensure that methodology so that we can then focus on having the best possible support for our customers. So on the tools side, on the infrastructure, obviously we use Amazon Web Services. Configuration management, it's all Chef and Amazon CloudFormation. Chef comes with a command line interface called Knife. And Knife has various plugins that have been developed by the community that allow us to do various things. What we rely on mostly is EC2 and Spork. Spork's a plugin from the guys over at Etsy that's been very helpful for us. SCM, we use Git language for both development and scripting. We use Ruby, IDE Eclipse. We use, in the developer environments, we use Vagrant, which I'll get into in a few minutes. And then that's basically on the professional services side of things. So then on the managed services side, if we do provide those services to our customers, we utilize Xenos simply because they have an API call into Amazon. So as we add and remove servers, we can then have those automatically monitored within Xenos. And then we also use various SaaS solutions out there like PagerDuty and Pingdom for monitoring our infrastructure. And then lastly, we use ticketing, Zendesk, again, a SaaS solution, which has been very helpful, but that's kind of more for customer-focused tickets, and then Jira On Demand for our internal development purposes. And then continuous delivery, we use Jenkins. All right, automation and standardization. So the great thing about automation is that it actually leads to standardization. So for those reasons, anytime we develop a product or a service inside of, for our customers, we put it into a Chef cookbook. Once it's put into the cookbook, we've developed that product, we can reuse it and have a standardized process to build servers. And this comes in very handy because basically, we can use it as a backup and restore services for potential customers. We can put services, production websites, and reuse those cookbooks to build dev and test environments. And then we can also scale those systems and be confident in the fact that we have the same configurations across multiple systems. And we do all of this with Amazon CloudFormation as well, but won't get into too many details about that. Secondly, we use base cookbooks across all of our customers. So if you utilize, we build what I like to call our virtual data center on top of the cloud, but we have a series of cookbooks that are used across all of our customers. And those implement things like backups, SNMP configurations, monitoring agents, and user accounts. So by putting everything in there and rolling it out to all of our customers, we can assure that we have a consistent configuration across them. And then lastly, it's embracing DevOps. And this is more of a culture methodology thing. Everybody has a different definition of what DevOps is. My thing is what Ops Code says, which I like, which is infrastructure as a code. I'm not sure if they actually quoted that or not, but who knows. Infrastructure as code, which simply means that anything, all the changes that you make in your production or test environments should be done inside code so that you can then rebuild and replicate those things. Additionally, since we're both a professional services organization and a managed services organization, we have developers who are developing cookbooks and we have system administrators who are managing our customer infrastructures. But frankly, the two are really coming very much together. So that traditional wall between development and operations is falling apart. And where developers are developing tools and cookbooks that are orchestrating IT resources, and system administrators are no longer necessarily logging onto systems and doing that work, but instead coding configuration using Chef and whatnot. And then lastly, it's a DevOps-oriented workflow. So what we've kind of come to realize as on the IT side is that we've really had to learn how to develop code, right? So we're doing a lot of work in Git and a lot of work in Jira and other things to make that happen. So I just wanted to kind of go through a typical workflow that we have and sort of show how we utilize those tools. So let's say a customer wants a new WordPress site. What we do is we modify an existing Chef cookbook that we have. upload that cookbook to our chef server and make it available to all of the nodes that we have under management, create a role for that server so that that server knows which cookbooks to use and become, what type of server to become. We then test that on a developer workstation, which I'll get into in a second, and then we launch the actual production server and then commit those changes to Git. As I mentioned, we use Eclipse, so we develop all of our own cookbooks. However, we definitely utilize the community as well. So OpsCode has been very good at hosting cookbooks on their website, so you can download. I think they have up to upwards of 700 cookbooks at this point for different applications out there. So the point is, utilize what's out there in the community and modify it to make it your own. So once that cookbook has been built, what we do is we use a plugin called Spork, which just bumps it to a new version number. Then we upload that version to our chef server, doing a nice Spork upload. Once that cookbook is on the server, we then have the ability to make it available to all of our infrastructures. Now, that can be a good or bad thing. So OpsCode is this, the chef has this concept of environments, and so you can create a production, test, and dev environment so that when you launch your node and it configures itself, it knows which environment it's in, and it will then utilize the correct version of the cookbook that you have or the correct attributes that you want to set to it. So in this case here, we're using Spork to then promote the cookbook to the customer dev environment. So it's not going to production yet. On the role side of things, so as I mentioned before, each node has a role. That role consists of attributes and cookbooks and a run list. So here we state that the attributes for the WordPress cookbook is to use version 3.2.1, for instance. And you can put in there where you want to install it and those sorts of things. I've abridged this very, very much. You can also then say what you want the website to be named, those sorts of things. At the bottom, which is very important, is the run list. And here you can notice that we're using our own role, the Stratalux base role, that is the configuration of all the backups, SNMP, SMTP, and all that kind of stuff is inserted in there, so it runs all the various cookbooks associated with that. But then it also runs the recipes that turn it into a quote-unquote WordPress server. So we install WordPress and install VSFTP for FTP access. At this point, we don't necessarily want to launch this on Amazon, even though Amazon is very inexpensive generally. When you're doing cookbook development, you're launching things continuously, and it can take some time. So to speed up all that process, what we do is use a Ruby gem called Vagrant, which all it does is launch Oracle's virtual machine on your developer workstation, and then bootstraps Chef, and then runs Chef on it, so that you can then quickly develop your product, your cookbooks and recipes inside this environment. If it doesn't work, you just destroy it and fire up a new one. Eventually, you're happy with what you've got, and you want to then promote this to either a test or a production environment. For the interest of time, we're just going to promote this to production. So we promoted to the production environment. It is now version 8.0.8.10. At this point, we're ready to launch our EC2 instance. And again, we use a knife plugin called EC2. And here we're creating a new instance called Web1. It has the run list of customer web server. We give it the general groups, security groups, and SSH keys. Tell it which region to go fire up in, which AMI to use, what size, all that kind of stuff. And importantly, we also mention which environment it's going into, so it knows which version of things to fire up. So once we hit return here, it's going to do some API calls to Amazon, fire up that system, wait for SSH to come up, then SSH into that system, bootstrap Chef, and then run this process of convergence where it's going to install all of the various components that it needs. And hopefully, if we've done everything right, it just comes up and we're happy campers. At this point, what's nice is that we can then commit all of these changes into Git. So because we have version control behind all of this stuff, it's very helpful to commit both the cookbooks that we've put in place, but also the roles and the environments and all those sorts of things. And the nice thing is because it's under version control, we can then attach it to customer tickets that come in or bugs that are bugged in Jira and whatnot. So creating these artifacts are very helpful for us. So what are the benefits of this approach? First is we're reusing existing code. So because there's a lot of cookbooks out there and whatnot, we're getting help from the community by being able to to develop these cookbooks a lot quicker. We're obviously making our own changes. At times we commit back to the community. Secondly, we've got customer configurations that are saved as artifacts in Git. So the nice thing here is that with the whole infrastructure as code methodologies, we can restore systems or build new systems based solely upon the code that we've created, plus backups of the actual data. So those two things in tandem are very powerful in the sense of being able to rebuild systems. It can be used for DR purposes, scalability reasons, and the rest of it. Changes are tested prior to release to customers. So we're no longer having admins getting onto production systems, making changes, and then hoping that those changes will work. Instead, we're able to create a development environment relatively quickly, make those changes there, and then promote it accordingly. This is good both from a change management point of view, as well as an SLA point of view for our customers. And then lastly, we have standardized configurations. So by putting everything in code, we can standardize our own management and configurations across all of our customers, making our support and management of them a lot easier. And that's it. Thanks, and if you have any questions, feel free to email me. Appreciate it.
Thanks, Jeremy. Great. So now if I could have everybody come back up and we can field questions, I think we'll just kind of have the speakers come up this way and stand up here and you can just volley at them and they can respond.
That's good, Joe. No, thanks.
Yeah, this is a question for Jeremy. Have you investigated using test kitchen as well as Bagger?
We're evaluating that right now, but yes, we're familiar with Test Kitchen.
How do you fit the role column and chef with having a different version of roles, but I know people overlap in roles? That's a problem.
Yeah, people know Chef. So there's an open source product called Burkshelf. I don't know if you've heard of that. It's from a guy named Jamie Windsor over at Riot Games, and he addresses that exact problem. So we're evaluating that currently as well. It's a very dynamic environment, so a lot of new things are coming on board. But I would recommend checking out Burkshelf, Berkshef.
The question is also for Jeremy. I couldn't hear that question, though, but it's not a Google.
Oh, yeah, sorry, I should repeat it. Yeah.
Does the Chef environment, do you deploy into VPCs for the customers? And does your CloudFormation Chef deal with setting up the VPC or deploying into VPCs that are already established?
Currently, we're not using VPC. We haven't had that requirement yet. But my understanding is that, yes, the Knife EC2 plugin does support VPC. Sorry, the question was whether or not Knife supports VPC. Yes.
So what's the differentiation between monitoring using CloudWatch and Xenos? I mean, where do you strike the balance?
Xenos also has a CloudWatch API, so we do capture some metrics with it. What we're looking at, there's yet another tool out there that we're looking at, which is called Sensu from the Sonian guys, and so we're evaluating that as well, which has more of a, it's just more cloud friendly than even Xenos is.
My question is also for Jeremy. I noticed that whenever you had your knife command up, that it showed customer SSH key. Do you allow your customers to SSH into their boxes? And if so, what do you do with the Chef client keys? Because they could potentially then make calls to your Chef server and look at things like your data bags, if those have credentials in them and things like that, or potentially just download all your cookbooks for all your different clients.
Correct. That's a good point.
Guys, leave Jeremy alone, man.
What do we do there? Yes, we do give root access to some of our customers. I know that Chef, we use hosted Chef, and so it has authentication and one has granularity, where you can basically put things in different organizations. So we have one organization per customer. That's so they can only see what's inside their organization, not necessarily what's in other organizations. And then we use data bags, encrypted data bags for customer SSH keys if they do require access to those systems. In terms of the validation PEM, you're correct. I would have to go double check that, but good point.
So this is a question for Brian and David. So first off, what data, like what PHI data values are you actually storing in the cloud, and how much of a struggle was it to finally kind of get that past, security and the lawyers and all of that kind of stuff?
Yeah, so the question was about what kinds of PHI are we storing and how we're dealing with that. I know we don't do the whole model, right? I mean, it's...
Right. Yeah, essentially we have a small set of data that's PHI. Essentially, we're just looking at the patient names, their unique ID medical record number. There's some other things, that the hospital uses, like patient visit numbers. There's a date of birth there. The nice thing about Hibernate and JSIP in particular is you can really just tag individual data fields as encrypted, and everything else remains unencrypted. So it's very easy to configure that. And it really hasn't been so much of an issue. I mean, we're now sort of ramping up our sales, approach to hospitals with our work with kota, the organ donor affiliates. These are essentially brain dead patients, so it's been a lot easier. There hasn't been that layer of sort of bureaucracy and legal issues. We just had to sort of convince kota that we were maintaining the security of the data.
As a quick follow-up, do you have any plans on integrating with your PHR providers like Epic and a lot of them to kind of make that data available kind of to them and vice versa, and how are you planning on scaling after that?
Right. So with our in-hospital systems, we are already integrating with Epic, with a bunch of other providers of various services within the hospital. What we're looking at is, we're really looking to target first with our SaaS model some of the smaller hospitals that don't have the type of IT budgets and the infrastructure that the larger hospitals do. I think the larger hospitals are really going to be sticking towards, sticking to the in-house systems much more over the next, at least, 1 or 2 years. But looking at these smaller hospitals, this becomes a great option for them because they can pay a subscription model for it, and they don't have those kinds of integration challenges. However, we do see ultimately using virtual private cloud and integrating, directly with their back-end systems, we'll just sort of configure it. We see that as a definite roadmap and something that would be very easy for hospitals to understand. Did that answer your question? Okay.
Okay, good. I think he's happy about that too.
Please.
Did you evaluate any of the other AWS application services? Are you considering using something like Redshift, or can you only use an EC2 because of the flexibility of being able to do encryption within the instance?
Yeah, that's a good question. I mean, I think that, so the question is, are we going to use other EC2 or other Amazon services with this thing? I should point out that the data that we're storing is actually stored in RDS. We take advantage of RDS to simplify. It gets encrypted at rest based on the model-based encryption.
Well, not originally. I mean, RDS wasn't available when we first started with kota, but we've essentially, upgraded the system.
Right, and then Redshift was released, like, what was announced yesterday or something. But so,
Come on.
No, but I mean, it's actually really interesting. So Control Group works with a lot of different companies in the healthcare space, and we've been talking to many people from medical startups to large healthcare organizations, trying to help them find ways to innovate using technology. Control Group gets pulled in a lot of these situations because they don't just have people like me with friends like Brian, but we have a lot of other really intelligent people, both on the technical side and the policy and procedure side. They can sort of help an organization navigate both sides of that. Including things like the business associates agreement and stuff like that, because Control Group is, ready to stand with our customers on that.
I'll make one more point. I mean, we are looking at, one of the other issues that hospitals are very concerned about is availability. You don't want to be working on a patient and then have the system go down unexpectedly. So we're looking at not just replicating across availability zones, but in the future, being able to replicate across regions to ensure, if a region outage occurred, that we wouldn't even be impacted by it. And right now we're looking, we'd have to look to the future for support with RDS for that, but we can still use sort of, MySQL replication or sort of the built-in replication of these databases, currently if we needed to do that.
How do you protect your keys in memory?
Well, we basically use, we don't rely just on, AWS roles. We also use network security. We use Unix security permissions. So the protection, for memory is really being able to protect the root access to the EC2 instance, and that's something that just having good data, security practices within your organization is important. We obviously don't share these passwords outside of a very small set of users. I don't know if there's more that you want to add to.
Yeah, sure. I mean, and we do a lot of the things that like Jeremy's talking about, where we're with configuration management and full automation. There's really not a whole lot of requirements for people to administer these machines. They work in a very similar way to what you were talking about, where the machines come and go and configure themselves completely. So the human involvement is sort of diminished, so we can really lock the machine down and prevent access of any kind other than over the web interface.
So this is a question for Ben. You didn't really cover this in your presentation, but basically creators will upload basically unprotected IP into your system to do these tests. So what type of precautions do you take from that IP, a user being able to steal the IP of another one of your users?
That's a great question. So we actually have a service that synchronizes data. So once you, and that service, we encrypt the data as it goes up. And it's, we based on the user identity, we only decrypt the data when we need to. So we have a bunch of services that include rendering, simulation, analysis. So each of those, unfortunately right now, because we're rolling a lot of those out, a lot of those have slightly different implementation to that. But that's what we keep the data encrypted as long as we can.
I'm also in the medical space, so I run an electronic medical record system in the cloud, and we have a lot of large institutions that want to be AA with Amazon. So where does the buck stop with y'all? Does it stop with y'all?
So the question is about Amazon, the BAA, and where the buck will stop. I don't want to speak for Amazon, but I know that they're not signing BAAs for most of our customers, and that's, I imagine, your experience. I mean, Control Group has signed BAAs in the past for companies, one of them in the EMR space, actually, I think. The way we approach it, we have technical experts, policy and procedure experts. We work with you to refine your policies and procedures. We work with you to understand the technical system that you're running in, designing the appropriate controls and putting the things in place, and maybe even managing it. Control Group also runs a managed services organization so that we can manage things for you. And once we work that out, then Control Group is comfortable, signing a BA to work with you on that. I don't know if Amazon will ever sign a BA. I don't want to speak for them on that, but I think that there's a lot of, what we've really noticed working together is that there's been a lot of change. People interpret HIPAA in different ways. Some organizations are really comfortable with certain things and some aren't. So really a lot of it really comes down to us having conversations between our customers, interfacing between hospital IT and compliance and the medical organization to try to come up with the right solution. And we have a lot, we're really fortunate to be flexible enough to have a lot of tools, both technically, policy and procedure-wise, and sort of legal-wise that allows us to solve these problems.
Have you run into a scale issue encrypting at the field level yet for names and things? So search across them?
We haven't. We're a pretty young organization at this point, so but we haven't had that sort of issue. Kota is the use of Kota is really a handful of users at one time. Even in our largest hospitals where we're not running on the cloud, we may have several dozen users at one time on a single instance of the system. We haven't run into any performance issues with the encryption.
Yeah, the question's been, does it have to change things like
Yes. Yes, so I mean, historically we were a company that builds desktop tools. And the entire, all the things that we do when we move to services, we've had to change licensing models, pricing models. That's actually been an enormous change for our business. We're a rare software company in that we're, I think, 25 plus years old. And so that's actually been I don't know, that internally that may even rival the technical challenges we face.
Okay, well, thank you all for coming.